We will also consider some aspects of matrix calculus. And first of all, let me introduce the objects of calculus on matrices. So the first thing, we introduce the matrix function, which is just a matrix where the terms may depend on this t. So this is matrix function. Similarly, vector function, this is just a vector which elements depend on variable t. So this is vector function. And we said that the matrix function or vector function is continuous at some point. So a of t or x of t is continuous at some point c0 if all these elements, so each aij t or each xj is continuous at t0. And the same for differentiability, we say that these are differentiable if these all terms are differentiable. And also we can introduce the derivative if the matrix function is differentiable or the vector function in this case. So if a t is differentiable, then we define dA dt as a new matrix which consists of the derivatives of the terms of the original matrix. And similarly, we can introduce the integral, let's say from a to b, a of t dt, as the matrix which consists of integrals of aij t dt. For example, let's say a of t is the matrix 2 by 2 matrix function, and assume that we need to find a derivative of this. We just take each term and find the derivative of each term. So derivative of t squared plus 1 is 2t, derivative of cos is minus sine, derivative of e to the t is just the same, and derivative of 1 is 0. And assume we need to find the integral from 0 to 1 a of t dt. What we do, we find all the integrals. Integral from 0 to 1 t squared plus 1 dt, the integral of 0 to 1 cosine t dt, the integral from 0 to 1 e of t dt, and the integral from 0 to 1 of 1 dt. You can check that this is 4 over 3 sine 1 e minus 1 and 1. So this new matrix is the integral of this matrix a of t. And this, you can see that since these properties are pointwise or element-wise, all these differentiation and integration, they satisfy the same properties as usual differentiation for functions. So for example, okay, let's write properties. For example, if we take derivative of, let's say, CA, where C is a constant matrix, this is the same as take derivative of A and multiply by the C. Also, derivative of sum of two matrices will give us the derivative of A first plus derivative of b. And also the product rule also works here. Will be the a derivative of b plus derivative of a. But here the order is important, so the order in multiplication is important. Also for integration, the integral of a, say, plus b dt, of course, will be the integral of a dt plus the integral of b dt. And similarly for if we multiply by a constant some number, we will get this number out of the integration.